Your TV remote is a fully functional Arduino controller, and a pretty affordable one at that. The remote fires an IR LED in a specific pattern, but to survive interference from lamps and sunlight, that signal gets modulated onto a 38 kHz carrier frequency. The receiver has a built-in bandpass filter that passes only 38 kHz and outputs a clean digital stream to Arduino. That stream is a 32-bit NEC packet, the dominant encoding standard in Arduino projects. The packet breaks down like this: 16 bits for device address, 8 bits for button command, 8 bits for the inverted command used as an integrity check on the receiver side. Each bit is a 560 microsecond pulse followed by a pause. Pause duration is what separates a 1 from a 0. 1 is 1687 microseconds, 0 is 562. IR receivers come in two forms: bare sensor and module. Same internals. On a bare sensor, looking straight at the lens, left pin is signal, center is ground, right is power. On modules, pin order often differs. Read the labels on the board. What most tutorials don't mention, the vast majority of cheap modules are just the bare sensor broken out to 3 pins with no additional circuitry. At most, they'll add an LED with a resistor for indication. Any noise source nearby, a motor, a switching power supply, produces garbage instead of codes. Fix it with a 100 ohm resistor between the module's power pin and the 5-volt line, and an electrolytic capacitor of 4.7 microfarads across the supply lines. Isolated bench tests with nothing else running, you can skip it. Any project resembling a real device, add the filtering. Connect the signal pin of the module to digital pin 11 on Arduino, ground to GND, power to 5 volts. Install IRremote from the Arduino Library Manager. That's the book icon on the left in the interface. Critical point: you need version 4. If you have an older version, update it. Current release is 4.7.1. Included in your code with the .hpp extension, not the usual .h. In version 4, this is a hard requirement, not a style choice. Declare the receiver pin as uint8_t instead of int. Saves 1 byte. In setup, set serial monitor to 9600 baud, call IRreceiver.begin with the pin number your module is connected to. In loop, check IRreceiver.decode if a packet came in. Read device address and button command from the decoded IR data structure. Print both in hex format, then call IRreceiver.resume. That call is not optional. Without it, the receiver stays locked after the first received packet and never processes another signal. Upload the firmware, open the serial monitor, press any button, 2 hex values appear. Now for the next example. Press the button you want to use to turn the LED on and copy both values. Press the off button and copy its command. The address will be the same. Both buttons are on the same remote. Now the control logic. LED as the example, but the same structure works for a relay, motor, or anything else. After each received signal, read address and command into 2 separate variables. 2 conditions. If address and command match the on button values, turn it on. Match the off button, turn it off. In your own projects, check both values, not just the command. NEC transmits address and command separately, and commands collide constantly between cheap remotes built on identical chips with identical factory defaults. Addresses usually don't. Checking command alone means any remote with a matching button code will control your device. Upload the code to Arduino and let's see the result. As you can see, when I press the button I recorded for on, it turns the LED on, and the one for off turns it off. Now let's try a different remote. I know that this button on this remote generates the same signal as this button on the other one. Let me press it from the second remote, and it doesn't respond at all. That's exactly the result we want. Wiring diagram, full code, and library link in the description. See you next time.